Hey, good morning, Algebra 2. Today we're looking at problem set 49, which we're going to look at linear intercepts and transversals. Okay, the first example that we're dealing with here is dealing with some parallel lines cut by transversal, and then you see we have a triangle involved, and we need to find specific sides or specific angles in this problem. Okay, so let's use some of the properties that we know about parallel lines cut by transversal and maybe some angle relationships. And then whenever we look to find sides A and B, we will use some triangle relationships, probably some trig ratios that we've been dealing with. So to start off, first thing we should notice is this angle right here is 153 degrees. Okay, that's going to lead us to finding the other angles in the problem, like angle Z. Well, if that angle is 153, what does angle Z have to be? Well, they form a straight line, so Z should be 27 degrees. Okay, now if those lines are parallel, because of these little arrows here, means those lines are parallel, we can use corresponding angles, which if this angle is 27 degrees, then the angle on the other line, P, is also 27 degrees. So now let's focus in on that triangle. We have this as a right angle. We just discovered that's a 27 degree angle. The hypotenuse is still 7, and we need to find sides A and B. Well, this is where our trig ratios are going to come in, and we can start off setting up the sine of 27 degrees is equal to the opposite over hypotenuse. The opposite side is B. The hypotenuse is 7. And we'll calculate that in just a second. We can also use cosine of 27 degrees, which is the adjacent side, A, over the hypotenuse 7. Okay, so now we solve these. We start by multiplying both sides by 7. And this is where we type it in our calculator. 7 times the sine of 27 degrees. Pull up my calculator. This will be is equal to 7 times the sine of 27. 7 times sine 27 equals. You get approximately 3.18 for B. Okay, then we do the same thing to find A. We multiply both sides by 7. And so we have A is equal to 7 cosine 27. Multiply that, 7 cosine 27 equals. A is approximately 6.24. Okay, so for this lesson, you're going to see pictures just like this, given some parallel lines and probably a triangle in there, and we need to use all of this is stuff we've already done, using relationships from parallel lines to find some missing angles, and then set up some trig ratios to find some missing sides. Okay, we're just putting two lessons together that we've already done, dealing with parallel lines and dealing with the trig ratios, and just putting it together into one. So hopefully that's a pretty easy topic. Okay, the second topic in this lesson is dealing with finding an equation of a line given a graph. Okay, now this one's a little bit different in that we don't see exactly where the line crosses the y-axis. Okay, you need to remember whenever you find this equation of a line, it's still y equals mx plus b. Okay, and anytime it's a slanted line, we will have a y, we will have an x. We need to figure out the m and the b. Okay, so to do this, the first thing we need to do is find a couple of points on the graph where the line crosses right on one of those intersections, right on one of those grid points. Okay, so what I see is it crosses at this point, and this point, and probably this point. Okay, so you're going to need to look at the pictures in your book or on the papers or wherever we have these problems and find some of those points. Okay, we could list those ordered pairs. This one is the ordered pair 3, 0. 1, 2, 3, 4, 5. 1, 2, 3. This is 2, 6. And this is 4, 1, 2, 3, 4, 5, 6. Negative 6. Okay, now we need to find the slope between those 2 points. So we could either use a slope formula, y2 minus y1 over x2 minus x1. We could use that equation, or we can just make a right triangle out of this, any two of these, and count the rise and the run. Okay, from the point 30 down to 4, negative 6, we go down 6 over 1. So that's a slope of negative 6 over 1, or just negative 6. So that's my m. Now the challenge here is to figure out b, because I don't see where the line, if the line continued on up, I don't see where it's crossing the y-axis, so I need to find that number. Okay, so a lot of times this number will not be a whole number. It might be a decimal or a fraction, so we're just going to have to be prepared for that. So to find b, we take one of these three ordered pairs that we just found and plug in the x and the y value. If I were doing the problem, I would choose the 3, 0, because 0 is an easy one to deal with. Okay, so my y value is 0. I plug in the x value of 3 plus b. Now I solve for b. This is 0 equals negative 18 plus b. I add 18 to both sides, and I get b is 18. So now I have the two things I need to be able to write the equation of the line. I have the slope, and I have the y-intercept. So I write my equation, y equals m, which was negative 6, x plus b. And there's my equation. Okay, so the hardest part of this lesson is picking out those points where the line crosses on the grid, and then count the rise and the run to find the slope. Make sure you keep track if that's a positive slope or a negative slope, and then plug in a point to find your b. Okay, so again, not a whole lot of new with this topic. It's just a little bit different because we can't see exactly where the line crosses the y-axis, and that's the challenge. Okay, so this is lesson 49. We have the parallel lines cut by transversals and some trig ratios kind of blended together, and then finding an equation of a line, just given a small portion of the line, pick out the ordered pairs, and go from there. Okay, this is lesson 49. Good luck.